NASA's first ever sample from an asteroid is days away from returning to Earth. Welcome back to Techstination. I'm Fred Fishkin. Joining us from NASA is Jamie Elsila Cook, Deputy Director of the Solar System Exploration Division. Hi, Jamie.
Hi.
Really exciting weekend coming up. We're talking about the OSIRIS-REx mission. To begin with, give us a bit of an overview of what this mission has entailed.
So OSIRIS-REx is NASA's first ever sample return mission from an asteroid. It's the largest sample we've brought back from beyond the Earth since the Apollo mission. And it's been a 7-year round trip mission to asteroid Bennu to study the asteroid, grab part of the sample, and deliver it back to Earth. And on Sunday, that sample is going to be returned to the Earth, and the study of that sample can begin. It's really exciting. The launch was in 2016. The spacecraft took over 2 years just to get to the asteroid, and then spent about 2.5 years studying the asteroid before grabbing the sample and heading back to Earth.
And how far away was this asteroid?
The exact distance varies depending on where we are in the orbit, but the spacecraft has traveled more than 3.9 billion miles on this round trip journey.
Billion miles. Wow. It's a lot on the odometer, I guess. So as far as retrieving the sample was concerned, that was a really intricate maneuver to be able to do that, right?
It was. The spacecraft was designed with a touch and go sampler to touch down and get a sample from the asteroid surface. But one surprise was we expected the asteroid surface to have some smooth areas so we could find safe regions for the sampling to occur. When we got to Bennu and were able to examine it more closely, we found a lot of big boulders, the size of cars, the size of houses. So it took a lot of work to find a safe sampling region and to be able to go down, get that sample, and safely bring it back to the spacecraft and back to Earth.
Tell us about the return mission now and what happens, what's actually going to be happening this weekend.
Right, so on Sunday, the spacecraft will approach Earth and it will release the sample return capsule. That capsule is about the size of a truck tire. And inside that capsule is the sample of asteroid Bennu. It's about 1/2 pound of dust and rocks from the asteroid. The capsule will enter the Earth's atmosphere, parachutes will deploy, and it will land safely on the surface in Utah. The day after, on Monday, that capsule will be transported to NASA's Johnson Space Center in Houston. And then in the days and weeks to come, the curation team will open the capsule, document the sample, and start distributing the sample for scientific analysis all around the world.
What potentially could the value be? What are we hoping to learn?
So asteroids are material that formed right when the solar system formed 4.5 billion years ago. And so studying them lets us understand the origins of the solar system and also potentially the origins of life on Earth. The O in OSIRIS-REx stands for origins. So we're studying both what the asteroid is made of and also the chemical composition of it. What are the molecules that are present? Asteroids like that delivered their molecules and their contents to the early Earth's surface. So we really want to understand that inventory of ingredients that's present in asteroids.
We are all, as the song goes, we're all made of stardust, I suppose. Are we expecting to find anything new, something we've never seen before, or just?
Well, we don't know. We have samples from meteorites, which are bits of asteroids that land on the Earth. But this is our first time going out to it, for NASA's first time going out to an asteroid and grabbing a sample and bringing it back. We don't know if we're going to find things that match meteorites already in our collection, or if we're going to find something that's brand new. And I'm excited. My lab at NASA Goddard Space Flight Center is going to receive some of this sample, and we are so eagerly waiting to examine it and find out what's new, how does it compare to what we know, and what new surprises are we going to find.
And the sample will be shared, right, globally to some extent?
Yeah, so 75% of the sample is actually going to be archived for future scientists, future generations. But 25% of it is going to be released to over 200 scientists on the sample analysis team at over 35 institutions all around the world. And a portion will go to Canada and to the Japanese Space Agency for their contributions to the mission as well. So there's this giant team of scientists from all around the world just ready to jump on the sample as soon as it's delivered to them.
And then the work of OSIRIS isn't finished, I understand. Tell me what happens next.
That's right. After the spacecraft drops off the sample return capsule and the work gets started on Earth with the sample, the spacecraft does a redirect maneuver, and it's going to be renamed OSIRIS-APEX, the OSIRIS Apophis Explorer, and head off to visit another asteroid, the Apophis asteroid. It should get there in 2029, and it won't be able to grab a sample, but it will be able to make a series of observations and help us understand Apophis.
And how far away is that one?
That one, I am not sure of the details on that one, but I know that the spacecraft will arrive in 2029 at Apophis.
And the communications, when you're traveling that far away, how long do the communications take when you're trying to get, I guess, images and data?
So at the time of the tag event, when the sample was collected, it was an 18.5 light minute round trip, if I'm remembering that correctly. So almost 20 minutes for signals to get to and from the spacecraft, which meant that all of the sampling maneuvers and instructions had to be sent for the spacecraft to do autonomously. We couldn't have Earth in the loop making decisions in real time. So that's a challenge of doing these types of missions.
It's just amazing that you're able to do that and have a signal at all. I mean, sometimes we have trouble with our cell signals, don't we?
It's an amazing team, a giant team of really dedicated people working hard, scientists, engineers, mission designers, project managers, just a huge team that has led to this great mission success.
And when missions take this long, so many years, I assume some people are there from the start, but others you come and go, I suppose.
Yeah, with a mission this long, you have to think about succession planning. It's a chance to bring new people into the field and give them a chance to be involved. It's been a really nice mix of generations and of evolution of the team over the years of the mission.
I suppose you run into people now and then who might ask you, well, why are we doing this? Why is this important?
I mean, humans have always looked up into space and wanted to understand what's out there. And asteroids in particular help us understand our solar system and help us understand our own origins. Like I said, the O in OSIRIS-REx stands for origins. We have these questions about where did we come from? And missions like this can help us to answer that.
And I understand that people, the rest of us are going to be able to share in this and watch some of this taking place on Sunday.
Yes, please join us in our excitement. Starting at 10 a.m. Eastern, there will be live coverage on www.nasa.gov. And you can also look for @NASA on various social media channels. So on Sunday, there will be live coverage. And then in the days and weeks to come, you can look for further updates from the mission team.
And I guess like other missions, we'll be holding our breath to make sure that the hope that parachute deploys properly. Is that the big question mark?
We will all take a good, deep breaths of relief once the sample is safely on the ground. But there have been a lot of rehearsals, a lot of planning going in. We're very confident that it's going to land safely.
Well, a lot of excitement. Congratulations on all the work that you've done thus far, and we'll have our fingers crossed. Jamie Elsila Cook, thank you for spending time with us.
Thank you.